Alright, hey Math 1 students, we are diving right into Module 5. So we're starting out with the 5.1 Ready, Set, Go notes. These notes are going to talk us first through graphing linear functions given an equation. So we really want to talk about the difference between these two forms that we've already dealt with in Math 1. So the first of these forms is slope-intercept form. So slope-intercept form says y equals mx plus b. The other way that we sometimes write it is we might write the b first, that y value, and then do plus mx. But regardless, the whole point of slope-intercept form, remember mathematicians are not creative, alright? Slope-intercept form is called slope-intercept form because it gives us the slope and the y-intercept. Alright, slope always tells us how to move, and then our y-intercept gives us our starting point. So it's always the point 0b. Alright, so again, here's our slope then, that's the m value. And then the b value is that y-intercept. So it doesn't matter which way we write it, they give us the same thing. But the point is, they're not creative, okay? So what that means is if I look at this equation that I'm given, here's my slope, and here's my y-intercept, that's my b value. So if I'm told that b equals 4, it means that my starting point for my line is the point 0.04. I'm also told that the slope is -2. And we have to remember that slope is rise over run, and so we're going to write it as a fraction, -2 over 1. So we're going to go ahead and graph this point, or this line then. So plot the point 0.04, so 1, 2, 3, 4, on the y-axis, which is right here. And then we're going to use our slope. So since slope is rise over run, that means I'm going to go down 2 and to the right 1. So down 2 and right 1. And then I always encourage my students to make as many points as possible on their coordinate plane. And the reason for that will become clear as we move farther along into this module. So just go ahead and fill out as many points on this graph as you can using your slope. And then we're going to use a ruler and draw a line. So again, this equation was given to us in slope-intercept form because they gave us the slope and the y-intercept. So now let's talk about point-slope form. So point-slope form can be written like this: m times x minus x1 plus y1. Or sometimes you might see it written with the y1 first. So y1 plus m times x minus x1. Again, mathematicians are not super creative here, guys. This gives us a point and a slope, all right? So our slope is m, just like it was in the other equation. And slope always tells us how to move. And then the other piece of information that they give us is this x1, y1 gives us our starting point. It gives us a random point on the line. And really, what's special about it is nothing. It's not the y-intercept. That's the only thing about point-slope form, is it gives us some random point that's not the y-intercept. So if we take a look at this equation that we're given here, I'm actually going to rewrite it as -2 times x plus 1 plus 6, because we do want to make sure we're used to seeing it in this form, because usually the slope comes first. So that means our slope is -2 over 1. And now we need to figure out what our starting point is. So hopefully this is review. We take the opposite of what's inside the parentheses, and then we take our starting y value. So that means I'm going to start at the point -1, 6. So -1, and then 1, 2, 3, 4, 5, 6 is right here. And then I'm going to use my slope, which I know means rise over run. So I'm going to go down 2 and to the right 1. So down 2 and right 1. Down 2 and right 1. And again, fill in as many points on the coordinate plane as you can, because you want to make sure you are used to using all of the coordinate plane. And then we're going to go the other direction also, so up 2 and over 1, up 2 and over 1, and we're going to go ahead and draw the line. So, one thing I want to point out to you guys is hopefully you should be able to see that these two lines actually had the same slope. We went down 2 and right 1 for both of them. In this example, because it was in slope-intercept form, we started at the point 0, 4, and then we used our slope. On this one, which was in point-slope form, we started at the point -1, 6, and we used our slope, which was down 2 and right 1. The cool thing here, you ready for this, is that for these particular equations, they're actually the same line. If we look, this red line crosses the y-axis, 1, 2, 3, 4, at the point 0, 4. So because these two lines actually have the same slope and the same y-intercept, they are exactly the same line. All of the points on this line in purple are the same as the points on the line in red. We just started at different places. Alright, so being able to tell the difference between your two forms is really important, but then being able to see that they actually give us the same line sometimes is important also. So I just want to make sure that you guys understand, for slope-intercept form, it gives us the slope and the intercept. And then for point-slope form, it gives us the slope and some other starting point. Alright, so a lot of times the difference between them is that point-slope form has these parentheses and slope-intercept form does not. So even if they're written backwards, if your equation has parentheses, it's probably in point-slope form. Alright, so being able to identify the two different forms is going to come into play later on in this chapter. Okay, so let's move on. The next part here that we're going to talk about is figuring out whether a point is a solution to an equation or not. So we have this equation, y equals -4x plus 5. So there's two ways that we can test solutions. We can test them with a graph or with the equation. So we're going to go ahead and make the graph just for some practice. So we're going to figure out here that this is in slope-intercept form, which means our slope is -4, which we're going to write as -4/1. And we can see that our b value is 5. So our starting point is the point 0, 5. So 1, 2, 3, 4, 5. And we're going to use our slope. Since it's -4/1, I'm going to go down 4 and write 1. 1, 2, 3, 4, and then over 1. 1, 2, 3, 4, over 1. And go ahead and fill in as many as you can. So that we can get a good clear picture of our line. And then use the ruler to draw the line all the way through. And make sure you put arrows. Okay, so let's figure out whether these points that we're given are solutions to this equation or not. So for the first one, we've got this point 2, -3. So I'm going to go ahead and actually just plot that point on my coordinate plane. So 2, -3 is this point right here. And we can see when I plot it, it's actually lying on the line, which means that yes, this is a solution to this equation because it falls on the same line that we already drew. And then let's go ahead and take a look at the point -1, 1. So if I plot the point -1, 1, that's right here. -1, 1, and we can see that that's not a solution to the line because it doesn't even fall on the line. So when we graph a line, the thing we have to remember is all the points that we put on it are solutions to the equation. So when this point falls on the line, that means it's a solution. When this point doesn't fall on the line, it means that it's not a solution. Alright, so again, the graph is a visual way to represent all of the solutions to an equation. But we don't always have the graph, and we don't always want to make a graph because it's kind of annoying. So a lot of times what we can do instead is we can actually use the equation. So I'm going to go ahead and divide this in half here. And we're going to go ahead and write the equation up at the top. So y equals -4x plus 5. And I'm going to write it twice because I have 2 points that I need to check. So the first point that I want to check was the point A, which was the point 2, -3. So if I want to check and see if that's actually a solution to my equation, then the other thing I have to remember is if I have an equation and I have a solution, then it makes the equation true. So in other words, I'm going to take this point, which is xy, and I'm going to plug it into my equation. So my y value is -3. And then my x value, so I'm going to take out the x, and I just always like to put parentheses. My x value is 2. So we can see this is my equation. It's y equals -4x plus 5. And all I did is take out the x and the y and put in my coordinate point. So now I've got -3 is equal to, and I'm just going to use my calculator to figure out what all this junk is equal to. So -4 times 2 plus 5 gives me -3. So if I look, -3 equals -3, that's a true statement. So then I would say, yes, 2 -3 is a solution to the equation. And this work that I showed here is my justification for it then. Let's do the same thing, but now we're going to test our other point. So now we're going to test the point -1, 1. So again, this is my x value, this is my y value. I'm going to take out the y and put in the y value that I think it should be. So 1 equals -4. And then the x value that I'm thinking is -1. So again, this is still y equals -4x plus 5, but I took out the y and the x and I put in the solution that I am checking. So now let's see if this is actually true. So here we've got 1 equals, and then let's use our calculator, -4 times -1 plus 5, and we get 9. Well, if we think about it, 1 and 9 are definitely not the same number, right? So what this means is no, this is not a solution. -1, 1 is not a solution to the equation. So if we look, we get the same answer for both of them, right? On whether we look at the graph or the equation, 2 -3 worked, right? It gave us a true statement, or we could see that the point landed on the line. Whereas over here, the point did not lie on the line, and it gave us a false statement when we checked it in the equation. So you can check your solutions either way. A lot of times it's faster to just do it in the equation because we don't have the line. Okay, moving on, one more thing that we have to talk about, and this is a major review because it's something that we did just recently in Module 9. We have to write the equation of the line that's shown. So we're going to write both of the equations, if we can, in slope-intercept form. So we're going to find the slope and the y-intercept. So we can see right here that this has a nice y-intercept. The b value is 2, right? This is the point 0, 2. And then we have the point 3, 0 crosses nicely for this line. We have two ways of finding the slope. We could either do rise over run, or we could do change in y over change in x. So I'm going to do rise over run, which means I'm going to do -2. I went from here to here, I went down 2, and from here to here, I went over 3. So that means then that my slope was down 2 and over 3. So the equation of my line is just y equals -2 over 3x plus 2. Alright, so if we look at the second one, again, try to find your y-intercept first. That's always going to be a good point to have. So if this is my y-intercept, it means b equals -1. This is the point 0, 1. This right here is the point 4, 0. Instead of doing rise over run, I'm going to show you guys really quickly how to make that table and do the change in y over change in x, just as a quick review. So if I make my table, I have the point 0, -1, and I have the point 4, 0. So change in y means what's happening to the y values. So I went from -1 to 0, which means I had to add 1. And then change in x means what are you doing to the x values? I went from 0 to 4, which means I had to add 4. So if my slope is change in y over change in x, then that means my slope is positive 1 over positive 4. If you want, you could also count, but being able to make the table is helpful when the scale is weird on your graph. So just keep that in mind, okay? But we've got our slope is 1/4 and our b value, our y-intercept, is negative 1. So our equation is 1/4 x minus 1. Alright, hopefully you guys got all that down. We are going to do tons of practice in class. Make sure you keep up on all of your stuff for Module 5, alright? And ask questions as soon as you have them so that you don't fall behind. We'll see you in class.